In this video, two tables are given to us. One table represents a linear model, and the other table represents a quadratic model. And we have to find out which table is linear and model and which table represents the quadratic model. Let's start with the first table A. We will rewrite the table vertically, and we will find average rate of change. Average rate of change is the same as slope in a linear model, and the formula is y2 minus y1 over x2 minus x1. So for the first row, it's not applicable. Second row will look like this: 25 minus 12 over 1 minus 0, and it will be 13. Next, 46 minus 25 over 2 minus 1, and we will get 21. Next will be 75 minus 46 over 3 minus 2, and it will be 29. Next, 112 minus 75 over 4 minus 3, and it will be 37. So average rate of change represents a linear model. We see that all average rate of change are not the same, so the data is not linear. Now we will find the average rate of change second degree, or a short way, ARC2. First line is not applicable, second line is not applicable. Now look how we will find ARC2. We will take 21, average rate of change between 1 and 2, minus 13, that is average rate of change between 1 and 0. This will be my y2 minus y1, and x2 will be 2, x1 will be 1, and it will be 8 over 1, that is equal to 8. Again, 29 minus 21, 29 minus 21 over 3 minus 2. It will give us 8. 37 minus 29 over 4 minus 3. It will give us 8. Now we see that all average rate of change second degree are the same. It means this data represents a quadratic model. Table A is the quadratic data. Because all the ARC2s are the same. Okay, now we need to find the equation of this data. Because we said this data is quadratic, we will use the formula y equal to ax to the second plus bx plus c. We will use the first 3 points, 0, 12, 1 and 25, 2 and 46. We will substitute these 3 points into the equation ax to the second plus bx plus c is equal to y. It will be a 0 to the second power plus b times 0 plus C is equal to 12. A 1 to the second power plus B times 1 plus C is equal to 25. A 2 to the second power plus B times 2 plus C is equal to 46. We will simplify this equation. 0 to the second power is 0a plus 0b plus 1c is equal to 12. 1a plus 1b plus 1c is equal to 25. 4a plus 2b plus 1c is equal to 46. Now we will use a method solving system of linear equations by using a calculator. If you are not familiar with this method, please watch a video that is posted on Blackboard. From this system, we will write the matrix 0, 0, 1, 12, 1, 1, 1, 25, 4, 2, 1, 46. We will use our calculator, and if you follow the steps that I showed in the video how to solve a system of linear equations by using a calculator, you will see that A is equal to 4, B is equal to 9, and C is equal to 12, this column. So the equation is 4x to the second plus 9x plus 12. Now we will review the second table, and we will start with average rate of change. We have to use the formula y2 minus y1 over x2 minus x1. The first row is not applicable. Here it will be 25 minus 12 over 1 minus 0. It is equal to 13. 38 minus 25 over 2 minus 1, it will be equal to 13. 51 minus 38 over 3 minus 2, it will be equal to 13. 64 minus 51 over 4 minus 3 is equal to 13. We see that all average rate of change are the same. It means our data is linear. The data is linear because all the average rate of changes are the same. Now we need to find the equation. The linear equation is y equal to mx plus b. M is a slope, and at the same time it is average rate of change. We found all average rate of change. All of them are equal to 13. B is y-intercept. When x is equal to 0, it's given to us in our table. B is equal to 12. So substitute m and b into the equation. And this will be our final answer.